Hello everyone, welcome back to another video lecture. In this lecture we are going to have animated videos. So we are not going to have a traditional chalk and talk. In this video lecture we are going to enjoy some concepts, very important concepts from Strength of Material Unit 1. And big thanks to E for Engineer channel for providing animated videos for Strength of Materials. I just put the link in the description box. Go and subscribe. If you're new to my channel, please subscribe and watch the playlist of Strength of Material 1 Unit 1. So without any further delay, let's see some videos. In Strength of Material 1 Unit 1, we'll see some animated videos on shear stress and strain. The first video is on shear stress and strain. Next we are going to see properties of material. Properties of materials. In that we have elastic property. Next we'll see Hooke's law. Next we'll try to understand the concept with animated video, modulus of elasticity. Last but not least, we'll see the concept of Poisson's ratio. So these are most important for exam point of view in JNTUH syllabus. So we'll have videos right here. So let us play one by one.
Stress. What is meant by stress? The internal resistance developed in a body per unit area due to externally applied load. Mathematically, the stress is defined as the load per unit area of cross section of the body or force per unit area. When a bar of certain material is subjected to load, it undergoes certain amount of deformation and then attains state of equilibrium due to the resistive force developed inside the material. The resistive force offered by the molecules of the section against the applied load is called stress. For the equilibrium, total resistive force developed must be equal to total load applied. Shear stress. Example of shear stress is double-lapped mechanically fastened joint. It is a stress developed or resistive force developed against shear force. Shear force divided by total area. Shear stress is denoted by Greek letter tau. Shear strain. It is a strain produced by shear force. In this case, the angular deformation produced by the load expressed in radians is considered as shear strain. Consider a rectangular block subjected to shear stresses as known in a result. The body is subjected to strain and the angle of deformation gamma is known as shear strain. Elasticity. Examples of elastic materials are rubber, steel. Elasticity of material is defined as the property of a material by virtue of which deformation caused by applied load disappears upon removal of the load. Steel, the body which remains its previous shape and size only when the deformation caused by the external force is within a certain limit. This limit is called as elastic limit. Plasticity. Plastic materials undergo continuous deformation. They will not regain their original shape after deformation when the external load is removed. Examples of plastic materials are lead and synthetic resins, etc. Malleability. It is the property of a material which enables it to be extended in all directions by hammering or rolling. Examples for malleable materials are ornamental gold, silver, copper, aluminum. Stiffness. It is the property of a material by which it offers resistance to bending action. Wood has lesser stiffness and concrete has high stiffness. Examples for stiff materials are mild steel, cast iron. Hardness. It is the property of a material by which it offers resistance to penetration or wearing, scratching, abrasion, machining and indentation. Example for soft material is talc, diamond. Materials used in cutting tools, dies, punches, etc. should have greater hardness number. Hooke's law. Beam is subjected to load. The Hooke's law states that within elastic limit, stress is proportional to the strain produced by it. Mathematically, it can be expressed as stress directly proportional to strain. Stress-strain curve. The salient feature of stress-strain curve are elastic limit, that is A, upper yield point, that is B, lower yield point, that is C, strain hardening point, that is D, breaking point, that is E. Limit of proportionality.
The stress strain curve is straight line from O up to a point A. The point A is known as proportional limit. Beyond this point A, the stress is no longer proportional to the strain. Upper yield point, that is B. Let us see the curve. It is indicated by point B on the elastic curve. Point A is the limit of proportionality, whereas point B is the upper yield point. Lower yield point, that is C. Let us see the curve. The curve falls from the point B to the point C. Between B and C, there is an increase in strain without increase of stress. This point C is called as lower yield point. Ultimate stress point, that is D. Let us see the curve. Point D indicates the maximum load which can be placed prior to the breaking of the specimen. It is the maximum stress attained by the material. The stress corresponding to the ultimate load is known as ultimate stress. Breaking point, that is E. Let us see the curve. After reaching the ultimate stress point D, the curve suddenly falls with rapid increase in strain. Hence, the specimen breaks at the point E. This point is called breaking point. The stress corresponds to the breaking point is called breaking stress. Modulus of elasticity. Within the elastic limit, the ratio of linear, that is axial, stress to the linear, that is axial, strain is known as Young's modulus or modulus of elasticity. Young's modulus is denoted by E. Young's modulus is equal to stress divided by strain. Poisson's ratio. Here we take a rod. The tensile load is applied on the both end of the rod. In longitudinal elongation, the length is increases in longitudinal direction. In lateral contraction, the diameter decreases in lateral direction. The compressive load is supplied on the both end of the rod. In longitudinal contraction, the length decreases. In lateral elongation, the diameter increases. The Poisson's ratio is lateral strain is directly proportional to the longitudinal strain. Poisson's ratio is equal to lateral strain divided by longitudinal strain.